Hello and welcome back to our Audit kickoff streams. My name is Jess and today we have another exciting project for you to dive into. Earlier today, our DIVA contest went live, and in this stream we're going to sit down with the developer and get some insight into this code base, get guided through it to give us that head start into this contest. As always, if you have any questions about this repo, please post them in the live chat throughout this stream, or head over to our Discord, which is linked in today's description, where the developer will be for the next week answering all of your questions. Now, before we get started, I would like to quickly highlight that this contest has an end slot of 519 lines. Let me just pull the contest page up onto the screen here, and we have $29 per end slot with a $15,000 USDC prize pool. This contest has launched today and it will run for 1 week, so make sure you are reviewing this throughout the weekend and throughout next week, as it will close next Friday. Now, let's get started. So before we do introduce the developers onto the platform, let's take a look at what this project is. So Aave DIVA Wrapper is a smart contract that acts as a connector between DIVA Protocol and Aave v3, allowing assets deposited into DIVA Protocol pools to generate yield by supplying them on Aave v3. The generated yield is claimable by the owner of the Aave DIVA Wrapper contract, and the Aave DIVA Wrapper contract was originally designed for DIVA Donate on Arbitrum, a parametric conditional donations platform which aims to use the yield to purchase insurance policies to increase donation payouts beyond users' initial contributions. However, the contract can be utilized for any other use case enabled by DIVA Protocol, like prediction markets and structured products. There were some tongue twisters in there, but I hope that has given us all a little bit of an insight into what this project is. But I think we'll get more insight when we do welcome to the stage Vladimir, who has made these contracts. So welcome to the stage. Thank you very much for joining us. Please quickly introduce yourself. Tell us a little bit about the project.
Yeah, thanks for the warm introduction. So my name is Vladimir. I'm based in Switzerland, and I'm the co-founder of DIVA Protocol, which is a smart contract to create all kinds of conditional payment agreements peer-to-peer. So some of them were already mentioned in the description, so prediction markets, parametric insurance, and yeah. And one of the applications that we built on top of DIVA Protocol is DIVA Donate. So how this works is basically users deposit funds into a programmatic escrow, or one step back, you define like a programmatic escrow. You basically define under which conditions funds will be released to people in Africa if drought occurs, and then users can contribute funds to that programmatic escrow. And if the metric that measures drought indicates that there is drought, funds can be claimed by the participants, the beneficiaries. And if there is no drought, you can take it back. So you see, this is basically like DIVA protocols enabling all kinds of conditional payment agreements. So I think it's important to understand that as a starting point. And now, what is this Aave DIVA wrapper about? Now in DIVA Donate, when people contribute, say $100, it sits there for 3 months without earning any yield, right? So what this Aave DIVA wrapper is doing, it routes the 100 USDC that you deposit, it routes it through Aave, supplies it on Aave, and then earns yield, right? And in parallel, it also creates this programmatic escrow on DIVA. And when everything is settled, you can take out the money as a participant, as a contributor, if there's no drought, say, and the yield is kept by the owner of the contract and can be used for various reasons, for various use cases, like buy additional insurance or fund operations of the platform. So it can be used in different ways, basically. And yeah, I'm happy to walk you through today through the contract, through the main functions, and give you like a high-level overview. And I think a lot of information will also be related to DIVA protocol, just to give you a little bit of an idea how this works. And yeah.
Yeah, absolutely. Yeah, if we will share your screen now then, Vladimir, and then we will get started looking through the code base. If we can quickly talk auditors through how to set this up and what the kind of user flow is, that'd be brilliant. So let's share your screen so we can get right into it.
Okay.
Oh, we've lost your screen.
Yeah, I'm sharing again. You see my screen?
Yeah, there we go.
All right. Maybe let's quickly look into the repository, and I think there are two main places where you find a lot of information. So there's the documentation.md file, where you find basically a description, also a chart, how these things work, right? And you also find example user flows. So exactly like I described just now. What is happening, right? What is happening if you don't use this Aave DIVA wrapper, right? So no yield is generated. And if you now use this Aave DIVA wrapper, you generate some yield and can do interesting stuff with that. Exactly. Then you have some terminology. So I was already asked in the Discord, what is a token? What is position token? So I think the best place to find out is just go into the documentation and read it once. It will clarify a couple of questions. And yeah, maybe we can also quickly go through the main terminology while we are at it. So there is this collateral token, right? So let's say you that the collateral token is basically the one that users contribute to this programmatic escrow. So it's typically USDC or USDT, for instance, like a stable coin. Position tokens are the tokens which basically are issued by DIVA protocol. So without this Aave DIVA wrapper, right? If you just deposit a collateral token, say 100 USDC into DIVA protocol, it will mint 100 long and 100 short tokens, right? With like directionally reversed payouts. So you can check out the docs.divaprotocol.io just to get an idea. So the long position token may have such a payoff pattern, right? And the short token is basically just reverse. So whenever it is like the maximum payout for the long token, the short token gets nothing. And yeah, and there's also like a parameterization of these curves inside DIVA protocol. So if you see terms like floor, inflection, cap, gradient, I mean, it's really like how the shape of these payoff patterns should look like. So you shouldn't be too worried about that. Exactly. What else? A token. That question I was asked in Discord already a couple of times. So a token, if you say just simply interact with Aave protocol, you deposit 100 USDC. What you get in return is one A USDC, and this one A USDC is rebasable, meaning that over time, whenever you check the balance, right, it keeps increasing with the interest you earn on the funds that you supply to Aave. So now, DIVA protocol does not support rebasable tokens. So for instance, I cannot simply deposit, so basically say deposit 100 1 USDC into Aave, then I get a USDC, right? And then use that as collateral into DIVA protocol. That does not work because then the accounting will break in DIVA protocol. So it's if you are interested to read the DIVA protocol docs, it's there's GitHub repository, also documentation, where all of this is stated. Don't be scared by the amount of documentation that is here. What we are using in DIVA, in this Aave DIVA wrapper, is just a small fraction of DIVA protocols. We're not using all the functionalities like EIP 712 features. Don't use it. We just use the core functions here. Exactly. So as I said, we cannot use A tokens directly in DIVA protocol. That's why we need so-called wrapped tokens. So if I go back to the chart here, so if a user deposits, say, 100 USDC into this contract that is up for audit, Aave DIVA wrapper, it will supply it or deposit it into Aave to earn yield, right? And basically Aave will return a USDC, 100 AUSDC to Aave DIVA wrapper. So it's held by this one. And now this Aave DIVA wrapper uses a so-called wrapped, wrapped representation of USDC and deposits it into DIVA protocol. And this wrapped representation is just a normal ERC20 token. So you, in the code base, as I was asked to zoom in, so there is this wrap token contract, very simple one, right? Exactly. And then when, say, the programmatic escrow, the campaign expires, the outcome is reported, right? Then users can basically redeem. Sorry, I forgot to mention one thing. Sorry, it's not drawn here, but DIVA protocol, when you deposit this wrap tokens into DIVA protocol, it issues short and long tokens. Let me show you from another article here. It's called insurer, but basically what happens, it means token A, call it long, token B, call it short token, right, to two different people. So in DIVA donate, where you have the donor, the contributor, right, he will receive one side of this programmatic escrow, the long one, right, and the farmer in Kenya will receive the other side of the contract. So when this, in step 3, when it's collateralized with the rep token, it issues short tokens and long tokens. Exactly. And then these short tokens and long tokens basically give you the right to come back, submit them, and redeem your funds, whoever receives the funds. So if there is drought, right, then the farmers receive funds, so they can go here, withdraw the funds, the $100 that was deposited. When there is no drought, farmers get nothing, but the original contributor or donor will be able to come back and receive the funds. And during this redemption process, the whole thing is basically reversed. So DIVA protocol, right? So you give back, say, 100 long tokens that you received as a donor. Then it will return the rep tokens to Aave DIVA, withdraw the A tokens that accumulated here. Let's say they're now 105, because as I mentioned, they're rebasable, right? So let's say after 3 months, they increased from 100 to 105. So now it withdraws everything from Aave, and now it just needs to send back 100 USDC, and the 5 USDC that were earned in yield can be claimed by the owner to fund operations or buy additional insurance, or do whatever they want, basically, right? So that's kind of like the core concept to understand here. And there are there's basically one main contract and it's let me show you how it's structured and explain why I did it like that. So you have the interface where you have all the structs, events defined, right? Very clear. All the functions. I will go through that in a bit. But what I want to say is, so you have the normal functions, but you also have batch versions of these functions, right? In the interface. Now there's this core, which is an abstract. So this, or no, let me go to the implementation directly just to show you. Now in the implementation, you see, okay, the normal function just calls another function from the core abstract. And if I go to the batch version of it, you see it's calling the same function. So basically, in order to provide all these batch functions for all the normal functions, I structured it in a way that all the internal functions that I used in the normal and the batch versions are placed here. So here you find basically the core logic, Aave, DIVA, wrapper core. This is the main contract to basically review. All right, so then we can, if there are no questions, let me check. Where am I? Oh, I'm lost. If there are no questions, we can dive into the code base. And maybe in the constructor. So when the contract is deployed, you basically need to provide the address of DIVA protocol and the address of Aave v3, right? Because as I said, it's a connector contract which interacts with these contracts. And you also need to provide the owner of this Aave DIVA wrapper contract who will be able to claim the yield. And this owner is updatable via the ownable two-step process that is provided by OpenZeppelin. So you set this up at contract deployment, make sure that the addresses are not zero. Obviously, I mean, it's important that you don't enter wrong addresses here at the time of deployment. So it's the responsibility of the deployer to ensure that. And then before you can actually use it, you have to register the collateral tokens. This goes back to the rep tokens, right? As I mentioned before, every collateral token that I want to deposit here needs like a wrapped version of it that you can view it as sort of as a liability, right, towards the user. And so you basically, the owner has to register them one by one. So let's say if you want your users to deposit USDC, so you have to register it manually. And obviously during that process, it will also check whether this token, say USDC, is actually a valid token on Aave protocol. Because as I said, I mean, it interacts with Aave, so you can just take a random token because then you cannot supply it to Aave. So if you use an invalid token, it will actually revert during the registration. Exactly. And then for USDC, if it exists, it will create WUSDC, like a wrapped version of this token. It will deploy it, and it will store or map the address of the wrap token to the collateral token. So there's a one-to-one relationship, right? And for reverse lookups, you also store, basically the reverse mapping. And then you also set some approvals because supplying to Aave or depositing into DIVA protocol, you need to set the approvals basically by Aave DIVA wrapper. So this is done here. It's max approval. Exactly. All right, and you can also read a lot of information in the comments. So I try to provide as much context and detail and as possible. So if that's not clear, feel free to reach out in the Discord, and I'm happy to answer. So let me go through the core functions here. So create contingent pool. This is basically just calling a function on DIVA protocol to establish this programmatic escrow. So basically, where users will deposit funds, right, and which will then mint long and short position tokens. But here it's basically like, think of it as creating a prediction market, right? So you have an event, you have you provide the time when it expires, and then here are the 4 parameters that I mentioned before, which define the shape of the curve. And maybe just to give you like a bit of an idea how the shape, the donation release profile for one of our donation campaign looks like. So you see it's very flexible. So this is now the short token that beneficiaries receive, and the long token is basically just directionally reversed. This is the long token is, goes to the original participant or contributor. Exactly. So this is exactly the same way you would call, you would create a pool when you interact with DIVA protocol directly. Now, the only difference here is that you don't use USDC to collateralize the pool, but you use the wrapped token of that. That's the only difference, right? So exactly. So very simple function, essentially. I mean, if you want, you can also go check out the DIVA protocol repository in, so if you go to pool, so it uses a diamond structure here, but if you go to create contingent pool, so in libdiva, create contingent pool, lib. So you find kind of like the basic logic here. As I said, it's depositing 100 USDC and then getting out 100 long and 100 short tokens. That's basically it. Right. Now, this is a one-off operation you do to establish the programmatic escrow or the pool. And then when users contribute funds to it, they would use the add liquidity function. And then you reference the pool where you want to deposit funds via the pool ID. So when this pool is created, it generates a pool ID. And then you also specify how much you want to deposit, say 100 USDC, right? And then you also specify who shall receive the long and the short tokens. For instance, for DIVA Donate, the long recipient will be the original contributor, and the short recipient would be the farmer in Africa, right? So these short and long tokens basically give you these contingent rights to claim the money from the escrow once the outcome and the payouts have been determined after expiration. So here, when you add, sorry, to go back, creating a contingent pool, I actually skipped one function, sorry for that. So when creating a contingent pool, or when adding liquidity, it's actually the same. Let's look at liquidity. It calls the same function. It's the same kind of like process. Add liquidity is just the same operation as creating the pool, but for existing pools. But the flow and is exactly the same. So handle operations. Okay. Yeah, let me show it on full screen. So handle token operations is basically implementing this flow. So deposit on Aave, mint wrapped USDC token, deposit into DIVA protocol. Yeah, exactly, that's it. So here you have the collateral token, right, from the user, say USDC. So you need to move it into Aave DIVA wrapper. Then this USDC you can directly supply to Aave. In return, you get a USDC, same amount. If it's 100 USDC that you supply on Aave, you get 100 A USDC, or the contract, the Aave DIVA wrapper gets it. And then you mint 100 wrapped tokens and use it to basically create, add it to the pool, basically, or create to fund or provide the collateral to this DIVA protocol. Exactly. So DIVA protocol in general is collateral token agnostic. So you can use whatever ERC20 token you want. It just shouldn't be rebasable or shouldn't be a fee token. And then, so now you have minted the wrap token, right? It sits basically in DIVA wrapper, and now you call the function add liquidity on DIVA protocol, and it will move the wrap tokens into DIVA protocol, and it will send back or mint the long and short tokens and send it to the specified recipients here. So you see also like the function naming is one-to-one to how it's done in DIVA protocol. Yeah, so this is the contribution side. Let me skip the remove liquidity function for now, just to avoid confusion here. But the more intuitive kind of like flow is, okay, now the campaign expires, right? Now you have to give it back. You give back the long and short tokens, or just if there's a payout. I mean, obviously, if you don't receive any payout, you wouldn't want to spend transaction fees to get nothing, right? So let's say there was no drought. The original contributor can now come back and say, look, I have long tokens, right? 100, and I want to get my money back, right? Which the 100 USDC. So he basically, so there are a couple of yeah, he's basically just preparing for all the operations here. And then what it does is it transfers the long token from the user to our DIVA wrapper. It then moves on to redeem the wrapped token, right? So wrapped token is basically you go to DIVA protocol and you pass on that long token, which is now owned by our DIVA wrapper. You pass it on to DIVA protocol, and in return, it will send back the wrapped tokens, right? But not to the user directly, but it will send it back to our DIVA wrapper, and then it will basically burn them and use and withdraw from Aave. So you basically also burn the A USDC tokens, and then you get USDC back from Aave, and then you send it back to the user. So I'm happy to explain it again, because I acknowledge it might not be straightforward. So let me explain here again. So the long tokens, so when the user comes back, right, he sends back the long tokens to Aave, and Aave passes this on to DIVA protocol. And DIVA protocol says, okay, this is a valid long token, right? And this user receives that much per long token, say one collateral token per long token, and the collateral token is here the wrapped token. So you get 100 rep tokens back, right? Aave DIVA wrapper gets it back. And now Aave DIVA wrapper burns it, right? It shouldn't exist anymore. This liability will be gone. And now that this is burned, you can now go and withdraw from Aave. So remember, Aave DIVA wrapper, when it's applied at the beginning, the USDC has received this A USDC tokens. Now it can go and withdraw it. So basically give back the A USDC, say it had 100 at the beginning and now it's 105 AUSDC, gives it back and receives 105 USDC. And now the delta, which is 5, will be kept by the owner, or it will be kept inside Aave DIVA wrapper, and 100 is returned to the user. I mean, there's also like a fee that is kept by DIVA protocol. So it's a little bit less, like 25 bips less, so 99.75 USDC, which the user would eventually get back, right? Let me check if there are any questions. Okay, no questions so far.
There are some questions, sorry.
Oh, really?
If you
I
go
don't see it.
onto the
Oh,
comments,
sorry.
there you go.
I was okay. Okay. Did they just arrive or
There's been a
okay,
couple. We can touch over them at the end if you'd prefer. It's up to you.
oh, maybe I can can you explain how short and long tokens work, how contracts determine how to pay out deposited tokens to farmers? I think I explained that in quite detail right now, but Nikolai, let me know if it's not clear. Happy to let me know here in the comments and I'll explain again. Anyone can create contingent pools. Yeah. Anyone can create contingent pools here, right? But you can only use registered collateral tokens because you need to make sure it's also available. You can supply it to Aave. But other than that, anyone can create it, right? That's not a problem. So if you say want to run a prediction market, you can also use this function, but you need to be aware that if I'm the owner, I will get the yield that is earned. So if you want to run a prediction market, you would rather deploy your own version of this Aave DIVA wrapper and set yourself as the owner. So while everyone could create this, it's probably not economically, probably not attractive to do that. So I would expect the owner to be the one that would create these contingent pools. Where the audit scope exclude? No, the audit scope does not include DIVA contracts. So DIVA protocol was already audited. So if you are interested in the DIVA protocol repository, there are audits, like find an audit folder, so you can find the audits there. So just, I think, yeah. Maybe I can highlight in this call also kind of like how the fees work. Yeah, let me do that in a sec. Who holds the AUSD from Aave? So it's the one that is supplying. So it's the Aave DIVA wrapper. So as I said, if the client is interacting with Aave DIVA, the user is interacting with Aave DIVA wrapper, and Aave DIVA wrapper is interacting with Aave Aave V3. So it's supplying the assets to Aave, and Aave is sending back AUSDC tokens to Aave DIVA wrapper. So Aave DIVA wrapper is always holding the A tokens, right? It should never leave the Aave DIVA wrapper. Who holds? It's Aave. Yeah. So this short token represents the yield. No, the difference. So so if someone deposits 100 USDC, right, there will be 100 wrapped USDC deposited at the end of this process into DIVA protocol, right? And yes, then long short tokens are shared. But the Aave DIVA wrapper is earning the yield. So the AUSDC is sitting in Aave DIVA wrapper. So say after 3 months, the AUSDC balance will increase from 100 to 105, right? And then when the operation is reversed, so when it's redeemed, DIVA protocol, so if you submit 100 long tokens, DIVA protocol will send you 100 wrap tokens back, right? And then our DIVA wrapper basically knows, okay, I need to send back to the user 100 USDC, right? Because it's a one-to-one. So USDC to wrap to USDC, it's a one-to-one relation. But our DIVA wrapper may have 105 AUSDC on its account. So it sends back 100 USDC and has 5 USDC left, which is the yield. So the yield is basically the difference between AUSDC balance and the wrapped token balance. Yeah, I mean, as I said, like read through the documentation, and I'm happy to explain if that's not clear. Could not get the short and long token position for like what it does represent. Let's think of a prediction market. Take the US elections, right? So there are funds. There are two people contributing funds into a pool, right? And now only one of them can win, right? So someone has the yes shares, and the other guy has the no shares. The payouts are directionally reversed. So if the yes shares get a payout, the no shares get nothing. If the no shares gets a payout, the yes shares get nothing. And think of this long and short as a more abstract version of yes and no shares. And why more abstract? Because instead of having this all or nothing payouts like you see in traditional prediction markets like US elections, you can also have, say, linear type of payouts, right? So for instance, I don't know if, say the floor is 100, the cap is 200, and it ends up somewhere at 150, for instance, right? Now, the ones that hold the long token get 50% of what is in the pool, and those that hold the short token get also 50%, right? And then the pool is depleted afterwards. So that's why think of it as yes and no shares, but the more generic way, because it may have different kind of like payoff profiles. Yeah, I hope this answers your question. And this is DIVA protocol specific. So if you want to read about short and long tokens, check out the documentation on DIVA protocol. Exactly. What I mean is, what's the source of truth? Maybe I didn't catch that. Maybe also because I see the flora is the reference below, which so the source of truth. I mean, there is an oracle, right? You need some oracle that will report the outcome. And in DIVA protocol, it's just an address. So DIVA protocol does not have an oracle. So it's like bring your own oracle type of approach. So you specify an address that will report the outcome. Can be like an individual, a company, or a multi-sig, or some other smart contract that will report. It's up to the creator of this contingent pool how he wants to configure it, right? And then this is kind of like considered the source of truth. But the oracle part is not relevant. So just assume there is some oracle, we report an outcome, and then there are these payouts. The reference asset will be the rept token. No, reference asset. Think of reference asset as an event. Maybe asset is a misleading term. Think of reference asset as an event. Let me show you something. Say a reference asset could also be just a string saying Trump wins. Okay. Or it could also be a link to JSON where the event is described. So think of it as reference event, not asset. So sorry about that. The rep token acts as the collateral token in DIVA protocol. So then how does pool know that, for example, should pay out farmers when the value of is not connected to drought? Yeah, the value of it's basically the how you define this programmatic escrow, the contingent pool. So when you set up a contingent pool, there are a couple of things you define. You define the shape of the payoff pattern, of the payoff of the long one, and then the short one is applied because it's basically just whatever is left in the pool, right? After the long one has claimed the funds. Then you have the expiry, and then you have the reference event. We call it reference asset, but it's basically like an event, the BTC price, or I don't know, a drought indicator that we're using. So that's basically how you set it up, and you also specify the oracle that will report the outcome. So the rep token is not at all basically connected, yeah, to this part. Rep token is just an accounting token to make sure you get the right payout. Yeah, the farmers are the shorter, while the depositors are the longer. Yeah, typically you would structure it that way. It's like short is basically you gain when the value goes down, like here, right? So the value, if it's low, it means there's drought. It means there will be a payout, right? So the token, the position that the farmer has this type of payout. So if the indicator NDVI is like just an index, vegetation index. If it's low, below 1.52, they will receive, say if it's 1.5, they will receive 50% of whatever was deposited into the funds, into the pool, programmatic escrow, and the remainder will be claimable by the contributors. If the value is 1.45, if the oracle reports 1.45 or something lower, then it means that 100% of the funds that are in this pool, programmatic escrow, are claimable by the farmers, right? And the original contributors basically now donated all these funds and cannot claim back anything. So that's kind of like the mechanism in DIVA Donate. Do the farmers stake to the pool? No, yeah, no. So no, they don't. So it's a donation, right? So what you're doing here is basically you donate a parametric insurance, right? So the farmer, if there is drought, he gets a payout. So in an adverse event, he gets a payout, but he doesn't pay anything because it's donated as insurance. But you could also use DIVA protocol where both parties contribute. So that's a typical scenario in a bet, right? So you have two parties and each party is expected to contribute, say, $50, right? So you can do these kind of things with DIVA protocol as well. But in this particular use case, DIVA Donate, yeah, there is just one party depositing all the funds and then saying that, okay, the short side will go to someone else. You can also use this, you can also deposit 100 USDC yourself and send the long and short tokens back to you, right? And if you want to get out the USDC, you would then use the remove liquidity function. So if you have both, say 100 long and 100 short, you give it back and you get 100 USDC back. But that's, I mean, that's why would you do that, right? So the normal way, if you want to do it, if you fund it yourself and send back long and short tokens to yourself, you could try to sell both to two different participants. So if you are a market maker, if you deposit 100 USDC, you get 100 long, 100 short back, and you try to sell, say, the short for 55 and the long for 60 maybe, right? And then you basically receive 115 back. So you deposit 100, you get 115 back. Now, but yeah, so there are different kind of like ways you can basically fund this pool. So it's either one party or two parties in DIVA protocol. In DIVA Donate, it's one party, but yeah, exactly. Can the tokens be redeemed at any time, or there is a minimal fixed time? So if you say own only the long, okay, or only the short one, you have to wait until the pool expires, and then you call the redeem position token function, give back your, say, long token, and then you get a payout. Now, if you, for whatever reason, have both, say, 100 long and 80 short tokens, I don't know why, but it could happen, then you can give back 80 long and 80 short back to DIVA protocol, and it will return you 80 USDC minus some fee, right? So it's sort of like wrapping. Think of it like wrapped ETH. Wrapped ETH, you deposit ETH and you get wrapped ETH back. It's a one-to-one relationship. In DIVA protocol, you deposit USDC, but you get two tokens back that represent a claim on the USDC, right? And if you trade one out, if you send one of the long and short tokens to someone else, or you sell it to someone else, right, then you have a risk that you don't get the 100 USDC back. So that's kind of like the basic logic. Okay, we should audit the product as if it could be used for the. Yeah, I think. Yeah, yeah, yeah. Yes. So I think. Yeah, I mean, there are two use cases. So right now you deposit funds, right, and you send, say, the short token to someone else. You donate it basically to someone else, right? That's the use case for DIVA Donate. The other use case you can do is you deposit 100 USDC and you send both short and long to yourself, and then and then you can try to sell it on the markets, on 0x protocol or Uniswap, like whatever exists there. Yeah, but these are the two use cases. So DIVA protocol has also like EAP features where you can sign like a commitment to, say, contribute like $50, and then only if a counterparty is found and agrees to the terms, they will also chip in 50, right? And then the transaction's happening, and then basically two different parties are funding the pool, and the short and long are sent back to them. But that's not part of this wrapper. So basically all this EAP functionality is kind of like not available. So it's actually just using the core functionality of DIVA protocol. So you have these two use cases. So let me know if that explains it. How are the users incentivized to fund from the donation? How are the users incentivized to fund it from the donation or yield? I'm not sure I understand your question, but the users that donate to this campaign, I mean, they just want to make an impact, right? They just find it cool what we're doing. They want to support farmers if there is drought, right? Just contribute. But rather than just donating to an organization and not knowing how the funds, where the funds go, you basically have here like you deposit funds and they're only donated if if there is drought, and you can also view it on chain what the outcome was, right? So it's kind of transparent, it's need based, and yeah, that's kind of like the motivation. I mean, eventually all the funds will be contributed. So if you contribute, if you deposit funds, there's no drought, you take it out, but then you would typically deposit the funds into the next campaign. So basically you provide insurance over many campaigns, and at some point there will be drought, and then they're donated, right? So they're gone. So that's kind of like the basic concept. Let me check. Okay. Let me give you also a little bit of an idea. Okay, so remove liquidity function. I skipped earlier, but I already give you like an idea what it means, right? So you give back long and short, same amount, and then you can get back the collateral token, and this you can do anytime, so even before expiry, right? So yeah, exactly. Let me explain you one more function: redeem rep token function. So when you redeem from DIVA protocol, let's say there are 100. Let's ignore the Aave DIVA wrapper, just normal DIVA protocol. You deposit 100, right? At some point, the outcome was reported and users redeem their payouts. Now, out of this 100 USDC, 25 bips, which is 0.25 USDC, is kept within DIVA protocol. So 25 bips of the collateral token will be kept inside DIVA protocol. So now, in Aave DIVA wrapper, the collateral token in DIVA protocol is this wrapped representation of USDC say. So when the redemption after the redemption process or during the redemption process, 25 bips of the or 0.25% of the collateral tokens, the rep tokens, are withheld by DIVA protocol, okay, as a fee. And the owner of DIVA protocol can claim those fees. Now, the rep tokens by itself, he basically needs to have a way to unwrap it later, right? So he would claim the fees from DIVA protocol directly, and then he would get the rep tokens. And yeah, now that's why there's also another function which is called redeem rep token. So if you you have rep token, you can basically go back and then it will burn them, and then it will kind of like so Aave DIVA would burn these, say it's 10 rep tokens, you give it back, it will burn them, it will send back a USDC. Aave will then send you back the equivalent amount of USDC, pure USDC, and then give it back to the user, right? I mean, what users could also do, the ones that hold the long and short tokens, right? They could also just go directly to DIVA protocol and claim it from there. So if the campaign has expired and they want to redeem it, rather than going through Aave DIVA wrapper, they could also go directly to DIVA protocol, give back the long token, and receive these rep tokens. And then in a second step, go to the Aave DIVA wrapper and call the redeem rep token function. So it's basically just, yeah, 2 steps, which you can avoid if you just call redeem position directly on Aave DIVA wrapper, which will kind of like unwind the whole thing in one transaction rather than having to do it in 2. So maybe that's also relevant to tell you. And you have the owner who can claim the fee, as I said, and you will also see it here. Get accrued yield. Yeah, get accrued yield function. So you see it here. there are two inputs you need to get the yield. So it's the A token balance, right? The principal plus the yield that has accrued since deposit. And you have the rep token supply, which basically represents or is a representation of the original deposit of the user, so one-to-one representation. So it's not rebasing or accumulating any yield. So it basically just says, okay, someone deposited 100 USDC and we wrapped it and deposited 100 into DIVA protocol. But the A token balance of Aave DIVA wrapper increases over time, right? And this difference, 105, say, minus 100, is the yield that accrues and is claimable by the owner of the contract. So that's kind of like it. And then the last function, then you have a few getter function, but I don't go into detail. Last function I want to mention, it's not super important, but if at some point, so in the you register it, and then you set the max approval. So there are implementation of ERC20 tokens. If this is done, right, and the allowance is used, then it will not reduce it if it's set to max. However, there's also tokens that would basically reduce it. That's also mentioned here. So if, I mean, in a highly unlikely scenario, there is a day where the allowance is depleted, everyone can just reset the allowance of that particular token. So that's basically it. And then yeah, you have the implementation. So this is the main contract, and it just kind of like pulls the core functions into here. So you have the only owner modifier, the non-reentrant. So I'm a little bit how do I say paranoid. So I put non-reentrant functions on all non-reentrant modifier on all the functions, even if they're not needed. But yeah, so put it everywhere except for getter functions. So check for how to say view function reentrancy. Shouldn't be there, but you never know. Exactly, and then you have just like batch functions. So a lot of the code lines or the dispatch functions add to the code lines, but in reality, I mean, there's like really nothing special about them. You just iterate and call the same function that you would call in the normal one. So, so it's basically just up to that function that needs to be reviewed, and then the collateral and the batch functions are pretty straightforward. Okay, you have the getter functions as well. Let me check. So let me check. Okay. Within the user donating to farmers claiming, can you take us through the involvement of much love from Kenya? Oh, great. Within the users donating to farmers claiming, can you take us through the involvement of Aave DIVA wrapper? Yeah, maybe we can, given that we have one. Are we constrained in terms of time, Jess?
No, please feel free to carry on.
Yeah. Okay. Maybe we can go through one specific example where we create such campaign, just DIVA protocol, like we did the last 3 times. So actually, if you want to read about the campaigns, you can go to diva.donate.xyz blog, and then you can read about some of the past campaigns, and just to get an idea what we're doing. And here's also an example where we use the Aave wrapper. So as I said, like Alice would go here, select the campaign. Now they're all expired. I cannot show it to you. But there's like, you can enter an amount and press deposit. So she deposits 100 USDC directly into DIVA protocol. So USDC is sitting in DIVA protocol. And then there's an outcome reported. So either, let's assume a binary outcome. So either the 100 go to the farmer in Kenya, or I can claim them back. So let's ignore the possibility that you can create like these linear type of payouts, which I've shown before. Okay, can either go to the farmer, to the beneficiary, or back to Alice. So that's the base case, minus some fee. So minus the 25 pips plus, it's actually 30 bips. 5 bips goes to the Oracle. But yeah, there's some fee, 30 bips in total. And yeah, there's no yield generated on that. And now, in the future campaigns that we're going to launch, so instead of directly calling the function add liquidity on DIVA protocol, we call the function add liquidity on the Aave DIVA wrapper. It's exactly the same structure of the function, like in DIVA protocol. And then, yeah, you just have this additional step which is implemented here. So you don't directly deposit USDC into DIVA protocol, but you deposit the USDC into Aave, right? But you also need to deposit something into DIVA protocol, right? Because it expects like an ERC20 token to be put into the programmatic escrow. And that's where this is the rep token. So it's basically the rep token is just like an accounting token for Aave DIVA wrapper to know, okay, someone deposited 100 USDC, I supplied it to Aave, but in the future, I need to give back, distribute that 100 USDC somehow, either to the original contributor or to the farmer. And in order to know how much my liability is, right, I create this rep token. I mint 100 USDC, I wrapped USDC deposited into DIVA protocol, right? And then if I receive it back, I know, okay, I need to send back 100 USDC to someone. So I withdraw from Aave, send 100 USDC to the user or the farmer, and whatever is left was generated in yield, I leave inside the contract, and it can be claimed by the owner of the contract. So let me know if that makes more sense. Remove liquidity. Yeah, let me explain it again. Remove liquidity. Yeah. Okay. So typically, if you deposit funds, right, you have to wait until the expiry. So let's assume a campaign. So once the short tokens are held by beneficiaries in Kenya and the long tokens by contributors, right? So they have to wait until the outcome is reported post expiry, and then they call the redeem position token function, right? Now, if you want to redeem collateral earlier, say you have 100 long tokens and you want to neutralize you want to get out. So what you can do is you can purchase 100 short tokens, right? And then you give back both tokens, long and short, equal proportions, back to DIVA protocol, and it will burn them and send you back 100 USDC. Okay, minus some fee. Let's ignore the fee for simplicity. So it's basically like a way to get out, to unwrap basically before expiry. As I said before, I compared DIVA protocol with rep token or wrapped ETH. In wrapped ETH, you deposit 1 ETH and you get 1 wrapped ETH back, right? And then if you give 1 wrapped ETH, you get 1 ETH back. Now in DIVA protocol, you deposit 1 USDC or 1 ETH. Let's call it 1 ETH to make it simple. 1 ETH. But then you don't get just 1 token, but you get 2 tokens, which combined represent the claim on that 1 ETH, right? So if you hold both, you can just submit both via the remove liquidity function and get 1 ETH back, right? because, and just the intuition, if you look at the payoff profiles, it's basically zero sum. So if you hold the long and short, if you sum up the payouts, independent of what outcome it is, you always get 100% of the pool. And that's why this operation makes sense. So 100 long, 100 short, you give it back and you get 100 USDC in return. So that's why it's there. I mean, there won't be too many use cases where people will use it, but it's kind of like part of DIVA protocol. Is remove liquidity not the same as redeem the token? I mean, you could, as I said, like redeeming a token, you have to wait until expiry. So let's say if you have 100 long and 100 short token, you can redeem them separately. So you can first redeem 100 long once the pool expires, and then separately redeem 100 short. That works. But you don't have to wait. If you don't want to wait until expiry, you can just call the remove liquidity function. Because, I mean, if you hold 100 long, 100 short, it's completely irrelevant what the outcome is, because, yeah, both combined basically represent a claim on these tokens. Okay, thanks. I was confused on the same function first converts and send the contract itself and then the recipients. Yeah, exactly. So yeah, I think that's pretty much it. So as I said, like the core one is the one that has the main logic, and the other ones, yeah. I think that the documentation is detailed enough. Let me check what I forgot anything. So yeah, basically everything that I described, how do you deploy a contract, what are the privileges, upgradability, or maybe that's one thing. So Aave DIVA wrapper is immutable. DIVA protocol is immutable. However, Aave v3 is upgradable, and there have been upgrades in the past. However, we're using just like 3 functions, and these are the core functions, right? Supply, withdraw, and then a getter function, get reserve data. So while there is a tiny chance that they might break the logic here, and then it will break the Aave DIVA wrapper, I don't expect this to happen, because I mean these are such core functions. But yeah, it's highlighted as a risk here. Oh, actually, I just noticed I also have nicer charts here, which I try to explain above. You see, it's been a while since I prepared the documentation. So actually, you can look at these charts. So they're actually main user flows, and you also see the flows of long and short. So this is pool creation or liquidity addition. As I said, it's basically the same operation. Liquidity addition, just depositing into an existing pool, but the flow is the same. And then you have position token redemption. Here you have the flow for a short token. And yeah, and then you have a couple of invariants that should always hold. So you should never face a scenario where the Aave DIVA wrapper has received, say, 100 wrap tokens from DIVA protocol as part of the redemption operation, but only has 98 tokens, right? Then it won't be able to meet its obligation. So it won't be able to send back the funds to the user because it only has 90. So this always has to hold. I mean, to be transparent with you, we're interacting with Aave, and Aave is also not without risk. So there is the risk of bad debt, right? So this could be a potential risk where we could potentially run into this scenario. Yeah, but I mean that's the risk you take if you want to earn yield on the funds that are deposited. And yeah, you also, so the wrap token supply should always be the same as the long and short token supply. So you should, yeah, it's basically a one-to-one relationship, but this is ensured, this is guaranteed by DIVA protocol. So yeah, so basically I think what this invariant says, you should never have a scenario where someone can create rep tokens out of nowhere and then be able to withdraw funds via the redeem rep token function. I think that's what it says here. And then you have like a function overview, and so here the core functions, owner controlled functions, batch functions, and then non-core functions, and for the special case, and then some getter functions. And then you can just click, and the structure is very is the same for all the functions. You have a general description, what the function does, also the execution steps. And here I spent quite a lot of time also looking into Aave protocol, what it does when it's calling supply, right? And then also revert conditions, under which conditions it reverts. And then you also see here that's okay, it reverts with error code 27, and that's kind of like in Aave. So I really try to be very, very explicit in trying to understand what is happening when there is a revert. Obviously, there are different types. You cannot capture everything. There are different types of ERC20 token implementations. So some of them might revert with different wording, or some of them have some blacklisting or some other special logic, right? Which, I mean, yeah, you cannot cover them all, but I try to be as precise as possible. All the emitted events. Yeah, so that's kind of like the basic structure of all the functions. So if you like to, if you look at the function, maybe read through these stuff before you dive in, just to get a general understanding, and then you can dive in. Yeah.
Amazing. Thank you so much for that, Vladimir. Is there anything else you'd like to cover?
No, I think that's it. Yeah. Any
Brilliant.
questions in the Discord then?
Yeah, absolutely. Yeah, as Vladimir says, if you have any questions that haven't been answered throughout this stream, then head over to the Discord, which is linked in today's video description. Vladimir will be in there throughout the duration of this contest, which is running till next Friday, to answer your questions. But I think we've really helped answer some of the odds to questions today. So also make sure to watch the stream a couple of times to completely understand the concepts involved in the protocol. That will definitely help give you a head start.
I'm also happy to jump on a call. So if in Discord someone wants to have a call discussion, a discussion on a call, if it's more efficient, I mean, I'm should be quite flexible. Yeah.
Amazing. Yeah, so there is a channel specifically open within the Discord to ask the questions, but Vladimir's kindly offered some time there throughout the week as well. So any questions, head over to the Discord to discuss them. Before we close off today's stream, I would like to say a huge thank you to Vladimir for answering all of those questions and giving us this deep dive into this code base. I'm sure it will definitely have helped give auditors that head start that they need to get into this code base before they do that thorough review within the week. So thank you so much for joining us. It seems like we have answered everybody's questions, so that is brilliant. So we can close off today's stream now. So thank you very much for joining us, and we will see you all next time. Goodbye.
Thank you and good luck. Bye-bye.